Hello, welcome to our session. This is Akhilan Ponnuswamy. I am a specialist with Red Hat, focusing on application platform. Today we are going to talk about increasing application modernization success with Red Hat OpenShift and YugabyteDB. So let us focus on why and how app modernization is adopted in this modern day and age. So some of the key values that we want to focus on regarding application modernization is, as you know, digitalization is everywhere. In fact, in the last 2 days, thanks to pandemic, the digital transformation has accelerated, and all the businesses and all the entities that you work with either have a digital first or digital only strategy. Some of the key reasons why more and more organizations are looking at digital transformation is to improve their digital presence. By doing so, they are able to improve their customer experience, gain competitive advantage, increase revenue and reduce cost, and also to mitigate risks. All the organizations are doing it. In fact, there is a saying about software actually eating the world. Now, software is driving the world as well. So there are a lot of different perspectives that comes in when actually customers embark on digital transformation journey. However, digital transformation is not all about building new modern cloud native applications. It also involves connecting and extending existing applications as well. Because if you're an organization who work on a lot of different applications, just to summarize or just to give you a perspective on a Gartner-based layering approach, you have applications that are distributed in your system of record, system of differentiation, and system of innovation. You may want to consider all the other applications that are deriving or delivering core business values as part of this journey as well. And applications do not live in isolation. Seldom you see new business initiatives delivered through modern applications that are kind of self-contained. When I say self-contained, these applications will still have to rely on existing systems and databases to share and access data. And then most of these applications leverage or connect to existing backend system applications, backend systems, applications, and databases as well. And some cases, you also see some organizational processes that are tied with these applications too. So you are already thinking about two different worlds. One is the traditional legacy world where most of the applications were built and then processed more organically on an on-premise ecosystem, and a modern cloud native ecosystem where applications are built on a cloud ecosystem following cloud native microservices, functions as a service-based architecture. So what are the challenges with that, right? So some of the common customer challenges, these requires two different ways to build and manage applications or extend applications. So maintaining and improving legacy applications, for example, requires a different mindset because these applications are slow evolving and they have typically a lot of additional processes and security, compliance, testing, certification that delay the overall life cycle. In fact, most of these applications follow waterfall development methodology that actually adds additional complexity as well, where it requires a longer upfront design budgeting cycle before the applications are built. And then the applications are tested, certified, user acceptance testing is done before it goes to production. And the modern way of doing things is about more agile, more cloud native, iterative development, where developers are able to use cloud infrastructure to build and deliver applications in an automated, secured, and a rapid iterative mode. So that is why there's a lot of two modes of operation adds additional complexities to the existing ecosystem. And also from the business challenges perspective, in order to deliver the maximum value, both these applications should work together. That is the traditional applications that are built and managed for a long time, especially in on-premise data center, and the modern cloud native applications have to work together to deliver business value, because most of these modern applications that are built in the cloud native ecosystem still have to talk to the backend systems, backend databases, and applications. And without having a consolidated and a cohesive strategy, we see that there are a lot of business challenges that are introduced, especially the evolution is slow. There is a lot of additional cost incurred, There is security posture is relatively weak, or new vulnerabilities are included or introduced, and then the developer productivity is not maximized, right? And so the way we can look at it is these complexities add additional technical debt, because the longer you leave the traditional applications stay as they are, which is basically the core business applications that are built in the previous generation, the more the technical debt is, and the more the technical debt is, the more complicated it gets when you try to modernize or migrate these applications over. So to summarize, even though the bi-model IT is something that is not practiced anymore, we still see a lot of organizations kind of have two different operating model, two different development and delivery approaches, one for modern applications and one for traditional homegrown or COTS applications. And that is actually the way bi-model is still alive in most of the enterprises or most of our customers. So just to give you additional perspective, so there was a study that was done by the Conveyor community in 2022. They spoke to 600 different companies on some of the challenges they face with modernizing the applications. And the core principal technology choices when customers are modernizing are the reasons for that are it is about maximizing the portability so that they can deploy applications in different infrastructure, be it their on-premise or public cloud, private cloud, so on and so forth. Increases productivity, which is basically ability to deliver applications faster so that they can deliver faster business value and also stay ahead of the competition. And also to improve security, because traditional applications were built to stay inside the core network. So some of the modern cloud security practices were not thought about or were not considered when they are built, right? So you can think of that as three different perspectives when in operation efficiency, so that how can you automate, how can you deliver better value from day one, and also innovation velocity, which talks about how developers can be more productive, and inbuilt security from all the layers that are part of your platform. And so the other perspective look at it is just moving out of the bi-model IT, that is having two different modes of operations, one for model application and then one for traditional workloads, and moving into a consolidated single and standardized operating model. Second one is how to assist innovation with flexible and scalable backend and data systems, so that you are not bound or slowed by the existing processes and existing data systems that were put in place for the prior generation applications, and also about security at foundation and all the layers across. Okay. So the barrier for application modernization as per the study or as per the survey is listed here. So just to categorize them, some of the key ways you can categorize these barriers are: one is fear of unknown, right? Because without you knowing what is in your application landscape, how these applications are delivering business value, it becomes much more difficult for you to start. And there is a lot of fear of unknown, because you don't know what is going to happen if you fail in when you are modernizing one application or one service that you are that is part of your core business day-to-day activity. Second thing is big bang approach. Typically, customers try to take it as a big bang approach and take, like, say, 400 applications that they have in portfolio need to be migrated to cloud within 6 months. So there are a lot of unrealistic big bang approach mindset that also adds as a barrier. And then the knowledge gap, because the traditional way of building applications and the modern way of building applications in cloud native world is totally different. And if you do not have enough skill sets and you do not have a good partner network to rely on, it will get more complicated, or it could lead to a situation where your modernization initiatives may not be successful at all. And then if you are not able to improve or show improvements on ongoing basis, especially if you are adopting a big bang approach with a lot of unknowns, it becomes far more difficult for you to show progress and win trust from the business stakeholders. So these modernization exercises are ongoing. So you're not going to take existing ecosystem and say, I'm going to modernize all my applications in a quarter, right? So it is going to take longer time. So it is very important for you to be able to demonstrate improvements on ongoing basis. And that is another barrier that was highlighted. And if you want to look at it, the overall value and overall risk mitigation of application modernization needs to factor in the business and the technology perspectives together. It is not a technology choice. It is not just a business value choice. It needs to be combined together. We will talk about it in the next slide, what we mean by that, right? So in order to address this risk, we have come up with a tool set called Migration Toolkit for Applications, which is part of the Cloud Native Computing Foundation project called Conveyor. It actually helps organizations understand their application landscape, prioritize what to modernize, and help migration teams scale. So how do we do that is, this toolkit has two capabilities that are built in. It has a automated analysis option where it can analyze source code repository, especially for popular development languages like Java and Node.js, help you understand for this application to be deployed into container ecosystem to be deployed on, let's say, OpenShift across a multi-cloud or a hybrid cloud ecosystem. These are the changes you have to do. So that analysis is done out of the box, and you have options to add additional rules that could match with your application architecture to leverage this automated analysis capability. On top of that, it also provides you with the assessment tool, which captures the value of the application and also the dependencies manually entered in the form of Q&A. So let's say you have an application ecosystem consisting of 400 applications. The analysis will be able to provide you with the technical capabilities or technical changes that is required for these applications to be modernized. And the assessment will be able to provide you with the business value as well as the additional dependency and the lifecycle management aspect of the applications that are captured. With these two information, you will be able to categorize the applications on the technical complexity and the business criticality or the business value these applications provide. And then leveraging this information, you'll be able to prioritize your migration journey or modernization journey, right? So that is how, leveraging Migration Toolkit for Applications, we help our customers do the business value analysis and the technical feasibility of the application portfolio in order for them to build a framework that is kind of aligned with the successful modernization strategy for their applications. And when we look at the application modernization strategies, it's a very very popular framework leveraged by Amazon, and it was derived from the 5R framework that was put together by Gartner. Across the 6 factors, the 2 factors that are very critical are the re-platform and refactor, right? Rehost is basically lifting and shifting. So you have, let's say, a traditional on-premise workload running on a virtual machine. You just take the same workload, deploy it on a cloud virtual machine. That's called rehosting. Replatforming is basically taking your existing application, not change the application, but just change the deployment unit. Rather than, let's say, a virtual machine on premise, you're going to containerize the workloads and deploy it to the cloud environment. And the refactor is where the maximum benefit is derived. That is when you actually refactor your existing application into modern cloud native architecture. So let's say you have a monolithic application that has follows J2E framework, which has, let's say, 200 EJBs. You are now breaking those monoliths into different microservices, follow cloud native development practices, and that is where you are deriving maximum value. So by doing the assessment and analysis I explained in the previous slide, you will be able to come up with a strategy that better fits your business criticality and the application architecture changes that needs to be done. And using that mechanism, you can identify either I want to rehost the application, replatform the application, or refactor the application and continue your journey. Okay. So by doing all of that and deploying the application onto a platform, we want to talk about the other perspective of it as well, right? Which is called the cloud native application platform. So as I mentioned earlier, so there are 2 aspects to building modern cloud native ecosystem. One is actually delivering new applications that are more containerized, more open hybrid cloud architecture enabled, and then modernizing existing applications. And we want to make sure that the developers are very productive in either of these options. So we call that as an inner loop, where the developers live and breathe. They can develop applications, they can do some assessment of existing applications, align with the business strategy or the business value those applications provide, and then modernize them together. So that is where the developers play a role. And then on the outer loop, which is basically the application delivery and then the automation capability to make sure that the applications that are developed or modernized follow organization best practices when it comes to security and compliance is taken care of. So this is where you talk about software supply chain, CI/CD, DevOps practices, continuous integration, so on and so forth. So a cloud native application platform provides you with a comprehensive ecosystem that takes care of inner loop as well as the outer loop construct that makes developers more productive when it comes to building new applications as well as modernizing existing applications, and also make sure they are able to deliver those changes faster, more consistently with best security possible to the target environments. In our case, it is going to be an open hybrid cloud ecosystem so that the application can be deployed anywhere the customer wants. It could be from core to edge to cloud and anything in between. So from the OpenShift perspective, Red Hat provides different points of deployments, different options of deployment, be it on-premise, self-managed, to completely managed cloud ecosystem on top of Amazon Web Services as well as Azure, called ARO and ROSA. And we also provide you with application development capabilities or framework that helps you to build modern applications as well as to modernize existing applications and connect and integrate those applications to the backend systems, called Red Hat Application Foundation. We also provide you options to deliver and build and manage the outer loop construct using ACM, which is Advanced Cluster Manager, and Advanced Cluster Security. So you can think of inner loop basically provided by Red Hat Application Foundation and also Red Hat Dev Spaces, and the outer loop, which is provided by Red Hat OpenShift in different deployment models, from the edge to core to cloud, from self-managed to fully managed, and also the life cycle management capabilities and secure software supply chain capabilities provided by ACM, ACS, and other tools in the OpenShift open source ecosystem. We also use Argo CD as part of our OpenShift GitOps. We also integrate with other static code review and analysis tools as well. So to summarize, what we provide is freedom of choice. The customers have different ways they can build and manage the platform. And we also provide a platform for both modernized as well as the cloud native workloads with our inner loop and outer loop constructs, with not only the platform, with the capabilities we provide with Red Hat Application Foundation and developer spaces. And also we provide a consistent platform not only for the applications, but also for the data workloads and other backend systems that you want to use as part of the ecosystem. Okay. So having spoken about the application, now let us speak about the data aspect as well, right? What is happening in data? So just like how we spoke about before, in order for you to build a modern cloud native ecosystem that can support and sustain modern applications as well as modernized applications that are traditional in nature, you need to talk about the same risks and same issues that happens with the application tier as well, right? So the bottom layer of infrastructure modernization is now really standardized because every cloud provider or every hybrid cloud ecosystem is becoming more and more container enabled or container orchestrated. So the infrastructure modernization at this point is, if you look at edge core to cloud, the deployment unit of choice is going to be containers, and the orchestrator, which is basically Kubernetes, is going to be the platform of choice. And from the application, we are looking at modernized applications as well as existing applications that are either packaged as containers or refactored to fit into the cloud native ecosystem. And then now, from the data layer perspective, we still have to modernize them as well, because some of the ways that traditional data layers were built with RDBMS, single node RDBMS systems like Oracle SQL Server, may not be compatible or may not provide you with the efficiency and the benefits the overall ecosystem requires when it comes to application modernization as well as new cloud native applications development. So if you look at from the data perspective, there were two different ways the data is now consumed, right? If you look at the monolithic applications, the COTS applications are three-tier applications that we are familiar with, be it Java frameworks or .NET framework. They leverage single node RDBMS. These applications were built for long lifetime or a longer release cycle, and the database mimics the same characteristics as well, right? But when it comes to cloud native ecosystem, we are looking at hundreds of microservices because the monolithic application is now broken into microservices and functions, and those capabilities require additional lightweight, distributed, and scalable database. Because if you do not have databases that are lightweight, distributed, and scalable, the data layer could become a bottleneck when it that limits your innovation capability as well as your modernization work streams as well. Because the data gravity could define how far the applications can be deployed away from, how simplified the microservices can be developed, and how faster they can be deployed. So it is all about the scalability, the flexibility, and the innovation velocity. All three characteristics will be affected if you do not select the correct data constructs when it comes to developing modern applications. So from the Yugabyte perspective, the way we see OpenShift and Yugabyte can combine or join forces together to address that is, Yugabyte provides the best possible distributed database ecosystem that is available, that supports both SQL and NoSQL constructs, right? Because there are three different workloads that are becoming more and more prominent in the modern cloud native world. One is the SQL workload, which is more transactional, NoSQL workload, which is non-relational, and then the streaming workloads as well. So when you're building your microservices, you are going to have two different data capabilities that are required if you're looking at it at the enterprise level. And Yugabyte actually provides you with the capability for leveraging a single database both for SQL and NoSQL. And from the cloud native distributed database for microservices architecture perspective, this is how we see Yugabyte helping. So with a distributed scale out database, you will be able to have a single cloud native distributed database, Yugabyte, deployed on top of OpenShift in an open hybrid cloud architecture that provides you with both Postgres as well as Cassandra API access for SQL and NoSQL workloads. And these workloads and the database can be deployed either as virtualization or on top of VM or as containers on top of Kubernetes. In our case, it is OpenShift. We do see a lot of customers and a lot of distributed data deployments becoming more and more Kubernetes native. So we will eventually see a point where your applications are containerized, your database layer is also containerized, and they are deployed on the same Kubernetes abstraction built on top of OpenShift. And then just to connect these things together, so you can see how the deployment comes together. We have Red Hat OpenShift as the foundation across edge to cloud or edge to core to cloud, supporting both the microservices applications as well as the Yugabyte database cluster that is distributed, that supports both SQL and NoSQL workloads. And then on top of that, we also provide you with the secure software supply chain constructs, leveraging OpenShift, advanced cluster management, and advanced cluster security. And from the innovation perspective, we will be providing with Red Hat Application Foundation that helps our customers to develop modern applications and also modernize existing applications. So just to summarize, why cloud native database on OpenShift? Because as I mentioned, two different reasons. More and more database deployments are moving towards container-based deployment architecture. So you will be able to standardize your application tier and data tier on top of OpenShift. That is number one. And also it helps you to improve density because having one deployment unit deployed on top of a consistent platform helps to improve density, both at the application tier as well as the data tier. And it also helps you to take all the goodness that the Kubernetes ecosystem provides when it comes to the state management, when it comes to the availability, all of those out-of-the-box capabilities that the Kubernetes ecosystem provides. Now both the application and the database tier will be able to take advantage of. And then it also provides you with improved availability, especially if you're looking at a hybrid cloud ecosystem from edge to core to cloud. Your platform availability is going to be significantly higher. Given that the platform availability is higher, the workload availability and the data workload availability will also be higher. And also it helps you to automate and standardize patching, upgrade, as well as the data operations to improve the efficiency. So just to summarize, we believe Yugabyte database and Red Hat's OpenShift will work hand in hand in delivering cloud native development and application modernization success by deploying OpenShift as the platform of choice across open hybrid cloud infrastructure. Thank you for your time. I'll stay around for a few more minutes for any questions. If there are no questions, have a great summit and looking forward to seeing you all on the field.